Today we are going to be talking about the tangent line problem. By the end of this video, you should be able to use the difference quotient to find the slope of the tangent line to any curve, and you should be able to find the first derivative and use it to calculate slope. First, let's take a look at this graph here. If we want to talk about the slope of this graph, it is different than talking about the slope of a linear equation because the slope changes. So when we are looking at the slope of a curve, we are looking at the slope of the line tangent to the curve at a given point. So if I choose this point and call it x1, y1, and I want to look at the slope of this curve at that point, I want to look at the slope of the line tangent to the curve at that point. So the tangent line would be about here. As you can see, this tangent line would have a positive slope. If we pick another point, say here, and call this x2, y2, and we want to look at the slope here, the slope of this tangent line is still positive, but it'll be a slightly smaller value. It is not quite as steep. If we look at the slope of the tangent line at this point, we'll call this x3, y3. Here our tangent line is horizontal, so it would have a slope of 0. And if we look at the slope of the tangent line at this point, x4, y4, this tangent line would have a negative slope. So, to get a more exact slope, we are going to use the difference quotient. So, let's take a look at this graph here. We know that the slope formula from Algebra 1 is that m is equal to the change in y over the change in x. So I'm going to pick a couple points on this curve. This point I'm going to call x, f of x. And if I pick a second point that is h away from our first point, then that means that the x value of this point would be x plus h. So this point would be x plus h, f of x plus h. Now, the line that goes through these 2 points is not a tangent line. It is actually called a secant line. But we're going to start here and we'll eventually get to a tangent line. So if I want to apply my slope formula using these 2 points, I would have the change in y, so f of x plus h minus f of x divided by the change in x, which would be x plus h minus x. And I'm just using the coordinates of the red and the blue points on my graph. So if I go ahead and simplify this, I have f of x plus h minus f of x divided by h. And this is called the difference quotient. As I mentioned earlier, the line that I've drawn on this graph is a secant line, not a tangent line. So instead of the blue point, I'm going to pick this orange point. And if I drew the secant line through that point, I would have a smaller h value. If I picked yet another point and drew the secant line, I would again have an even smaller h value. And you can see that the slope of these lines is getting closer to the slope of the tangent line through the point x, f of x. So what we want to do is make h 0. But if I plug in 0 for h in my difference quotient, I'm just going to end up with f of x minus f of x, which is 0, over 0. So to get around that, the slope of the tangent line through my red point, which is x, f of x, is going to be the limit as h approaches 0 of the difference quotient. So if I need to find the slope of the tangent line, this is the formula that I'm going to use. The limit as h approaches 0 of the difference quotient. So let's look at a few examples. First, I want to find the slope of g of x equals 3x plus 4 at any point. Now, this is a line. You should remember from Algebra 1 that the slope of this line is -3. So we already know what the slope is, but we're going to go through this process of finding the limit as h approaches 0 of the difference quotient and verify that we will still get -3 as our slope. So I have m equals the limit as h approaches 0 of g of x plus h minus g of x divided by h. If I plug in x plus h for x, I have -3 times x plus h plus 4 minus g of x, which is -3x plus 4, all divided by h. It is very important that you are careful with your negatives. The most common mistake here is forgetting to distribute this negative to g of x. So let's go ahead and do the algebra and start simplifying. If I distribute, I get -3x minus 3h plus 4 plus 3x minus 4 divided by h. Now, in the numerator, quite a few things cancel out. The -3x and the 3x cancel, the 4 and the -4 cancel, so I'm just left with -3h divided by h, and then the h's cancel. So I have the limit as h approaches 0 of negative 3, which is just negative 3. So, as we said originally, the slope of this function at any point is going to be negative 3. But we will not always get a constant. Frequently, we get a function. So let's take a look at another example. Here, I want to find the slope of f of x equals x squared at the point negative 2, 4. So I'm going to start the same way that I started the previous problem, by finding the limit as h approaches 0 of the difference quotient. So I'm going to have the limit as h approaches 0 of f of x plus h minus f of x divided by h. So when I plug in x plus h into the function, I have x plus h squared minus x squared divided by h. You do need to be careful with your algebra. We need to multiply out our binomial squared. So x plus h squared, FOIL it or double distribute it or whatever you want to call it. You get x squared plus 2xh plus h squared. If you need to show more work out to the side, that's fine. Now we can simplify our numerator. The x squared and the negative x squared cancel out, so I'm left with 2xh plus h squared over h. I'm going to factor out the GCF of h in the numerator, and then I can cancel that with the h in the denominator. So I'm left with the limit as h approaches 0 of 2x plus h. And if I plug in 0 for h, I now get that the slope is 2x. So as I mentioned earlier, we have a function as our slope. In this particular problem, we want to know the slope at the point negative 2, 4. So to figure this out, I'm going to take this function and plug in negative 2 for x. So I end up with the slope being equal to negative 4. If we wanted to find the slope at a different point, we could simply plug in that x value to our slope equation, which is m equals 2x. Let's look at another example. We want to find the slope at any point of m of x equals x squared plus 3, and then use this expression to find the slope at 2 points. So again, we're going to start with m is equal to the limit as h approaches 0, m of x plus h minus m of x divided by h. So if I plug x plus h into this function, I have x plus h squared plus 3 minus x squared plus 3 divided by h. If I go ahead and multiply out things in the numerator, I have x squared plus 2xh plus h squared plus 3 minus x squared minus 3 all over h. I can cancel the x squareds and the 3's. So I'm left with the limit as h approaches 0 of 2xh plus h squared over h. If I factor out a GCF in the numerator, that allows me to cancel that with the h in the denominator. So I'm left with the limit as h approaches 0 of 2x plus h. If I plug in 0 for h, I end up with the slope is equal to 2x, which is the same function that we had in the previous example. So now, at the point -1, 4, if I plug in -1 for x, I have that the slope is -2. And at the point 2, 7, if I plug in 2 for x, I end up with the slope of 4. Now, we have taken functions and derived an expression for the slope of that function. This derived function is called the derivative, which is a very important concept in calculus. The first derivative, which is represented by this notation here, you have f apostrophe x, which we read as f prime of x. That is the notation that represents the expression for the slope of the tangent line to the function. So to put everything together, we have f prime of x is equal to m, which is equal to the limit as h approaches 0 of f of x plus h minus f of x all over h. This is the formal definition of the derivative. So, if we have j of x equals 3x squared minus 5x, we want to find the derivative. So, j prime of x is going to be equal to the limit as h approaches 0 of j of x plus h minus j of x all over h. So first, I need to plug in x plus h into my function. Then I'm going to subtract j of x, which is 3x squared minus 5x, and divide everything by h. I'm going to skip ahead a little bit in the algebra, but you do need to make sure that you square the binomial, then multiply everything by 3. You need to make sure you distribute the -5, and that you distribute the subtraction. I'm going to do all of that in one step. If it takes you more than one step, that is fine. So I have the limit as h approaches 0 of 3x squared plus 6xh plus 3h squared minus 5x minus 5h minus 3x squared plus 5x all over h. Then I can cancel some terms. Those cancel, those cancel. So I'm left with the limit as h approaches 0 of 6xh plus 3h squared minus 5h all over h. I can factor out an h. Cancel that with the h in the denominator. So I'm left with the limit as h approaches 0 of 6x plus 3h minus 5. And then if I plug in 0 for h, I have that j prime of x is equal to 6x minus 5. So the derivative of 3x squared minus 5x is 6x minus 5. Lastly, I want to use this function to calculate the slope of j of x at the point 3, 12. So I have that j prime of 3, or the slope at 3, is equal to 6 times 3 minus 5, which is 18 minus 5, which is 13. So if I graphed j of x, the slope of the tangent line at the point 3, 12 would be 13.